Okay, so this is the first recording to making this one, and I will give myself 25 minutes. Alright, go. Construct the lexicographically larger valid sequence. Oh my god, even I don't know how to spell this. Giving an integer and find a sequence that satisfies on following. The integer occur once in the sequence. Its integer between 2 and n occur try in the sequence. Okay, so 1 only 1, 2 to n, go 2 times. For every integer I between 2 and n, the distance between the two occurrences of I exactly I. Oh my god, I exactly I. The distance between two numbers on the sequence I and j is absolutely different on the indice j and minus I. Return the lexicographical sequence is guaranteed that under the given constraint is always solution. Okay, always solution. A sequence A lexical larger than sequence B are the same length. If the first position where A and B differ, sequence A has number greater than the corresponding number B, for example. Larger than, because the first position they differ, that the third number is 9. Okay, really hard to understand. Let's go to the example. So giving the n number n equal to 3, the output will be 3 2 2 3 2, or even this is valid, but is the lexical larger font. Okay, so why this one is correct? Let's remove this. Occur once in the sequence. Okay, it says 1 in the sequence. It integer between 2 and n, so in here 2 and 3 occur try in the sequence. Try in the sequence. Okay. And then this is 1, the first condition. This for every integer I between 2 and n, the distance between two occurs of I exactly I. I hit an index, right? If hi is absolutely different. A second B has number greater than corresponding number B, for example. Because the first position they differ, the third number, the first position. Okay, so it has to be twice for every I. AI and AJ is absolutely in the indie. J is I. I don't get it. It have to be in this order. Okay, n is only 20 number here. Okay, let me see. So if it have 1 2 3, alright. So 1, I'll go only 1. This is check. Okay, it's between 2 and n, I could try in the sequence. So 1 is here, here, try the sequence check. For every integer I between 2, the distance between two occurrence of I exactly I. Every integer I. So this is 0, 1, 2, 3, 4. Every integer I between 2 and n. Is that 2 and n is here? No, 2 and n is 2 and n is here. The distance between two curve of I exactly I. Okay, let's see Lexicographically. Graphical order. Oh. Oh, okay, makes sense. Okay, so I between 2 and the distance between the two occur I exactly I. So 3, 1, 2, 3, 2. Is it because 1, 2? So distance here is 3 and distance here is 2? Is that how it's work? 3, 4, right? 4 minus 2 is 2. Oh my god, this is it. I understand it. So it takes me 7 minutes to understand what's going on. Not too bad, but let's get started. The next one. N equal to 5. So 5. Okay, so I have to order it in the distance, right? I know that 1 can be anywhere, so I can put at the side. And the order number 2 is have 2 times 3, 4, and 5, right? It can be at current 3. So this one will take 1, 2, 3, 4, 5, 6, 7, 8, 9. So there will be 9 position here from 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 position, is that 9 position? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 position. So first position I can put anywhere I want. Okay, so it's okay. The 2 have to be 2 distant, right? So the I and J here have to be 2 different distant. So the possible number that I can put is like here, here, or even so here. All right. So this is some of the thing I can put 2. Right? At least I know where to put 2, and 3 have to be 3. So if 2 places here, where the position I can be 3 is 1 here, 1, 2, 3 here, 3 here, and no, it's only 1 here, 1 here, or 1 here, 1 here. All right. 4 will be 1 here, 1 here, and 1 here. And 5 will be really difficult, right? Because 5 should be here. So the position 5 here will be fixed. Okay, we can see this one will be fixed. So we're gonna remove the 0 and the 5 here for 5. And then because this one we have to remove it, it's not possible if this one, so the only one here can be good. No, it's so it can be so how about 4, right? 4, if they be here, 4 will be 5, cannot do it. I have to move it up for number 2, and this should be number 6, and that's only 2 position of 4 left. Okay, this is really interesting. I know that 2 of the 5 here, this is only possible way. So let's think about which data structure that I have to use. What algorithm? I don't know algorithm, to be honest, and this is the first time I'm facing those kind of problem. And how about I go with the number 3 first, and let's make it make more sense here, right? So 3 will have 1, 2, 2, 3 here. So it always will be number of this minus and plus 1 will be, no, not plus 1. So 1, 2, 3, 3 character. So 3 have 1, 2, 2, 5, and 5 have 9. So it will be minus 1. Yeah. So the number, the index will always be n multiplied 2 minus 1 will be this. Alright. Okay, thing got interesting, but it's 11 minutes. I definitely cannot move on with the competitive programming, but it's okay. I will get there. Okay. So to put the number 3, I will go from the largest, right? Because that's what they want. Here and here. I only have 2 positions for it, right? So I know where to go. And what if I make this over here, right? So the next one is number 2. Number 2 can be here, and that's it. No, because 2 is already here, so cannot moving it, and I have to move it up here, and it makes sense. So it will be here as well, and the number 1 is the last position. Okay, so it seems like there's a pattern here. I can see there's a pattern here, but let me try with the number 5 again. 1, 2, 3, 4, 5, 6, 7, 8. Alright, there's a pattern here. What if I will take the number 5 here and here? This is, and there will be another 5 here. Go here, and another 5 here. 6. Well, that's a lot of position for 5, right? Okay. And how about we fill the number 4 here? If 4 here, it can be. So 4 here, fix. Okay, let's do it really naive. 3 cannot go anywhere, so I have to he cannot go here, so this scenario is not correct. We have to try again with number 4. every integer I between distance. The distance here, is that sliding window? Yeah, with me it's like it's kind of like sliding window here, but now is I have end window. Oh my god. I know that this one will have 9. This one will have 5. So 5 position. Right. This will make it larger. Right? For example this. Right, largest. But the next value here, if I want to make it 4, is that will be backtrack. Right, and then this is not good. And then this is one result. I can keep the result and then compare it, right? So this is what I call backtracking. Breadth first? No, this is definitely recursion. Right? So I will put the number here and on the possible case, and then I will recursively add the odd number. If there's no 0, which means that is good, and if it's good and there's some edge case, that the first edge case like this will be if the number is not 0, which is they already fill it, I will return false, so which means that it's not good. And if it's good, I will add it here. Seems like I almost there. Let me try to call it out. I mean, right now I don't know how to call it out, to be honest, but let's try to write something down, shall we? Okay, where are we? So we have always possible, and I will say the list, no, not list, will be result will be 0 multiple with n 1 y minus 1. Alright, this is the first thing. And the second thing is for I in rank of one and n minus 1. Okay. So start from 1, 2, 3. So if I want to fill over there, if I want to fill this, what should I do? I'm gonna need a recursive on this and figure it out. Okay, I think I get something here. So what if I will start from the index 0? I start from the index 0 here and I keep moving up. So for one time I'm moving up, I will recursive here and then try it. If it have results, I will store it and then I can compare it later. And then this I will be moving up to fill out the value. So it will be filled from 3 and 2 and 1. So if it's filled out this way, n will minus 1 for I in rank of len of the result, and so I will need some function here to like function check, and this check will have the index of I and n. Alright, this one will check it. If I will need to put the results in here as well, right? So I want to return the new things here as well. What if I put the results in here? Right. My result will be in here. Okay, my result will be here, and result and if check I will have the final equal to this. Append result. Oh my god, I think I will need like 7 more minutes. Alright, and then for numbers in final and equal to 0, output equal to max of show it up numbers. And then Okay, makes sense. So let's try to check that. Check my result will be current and okay. This one will be, yeah, no, it's not good. Current, yeah, I mean I put it because it makes more sense for me. Okay, so the SK will be if I, oh my god, I don't think it's gonna work, right? There's a huge problem with the logic here. I'm gonna need a J as well. Oh my god. Yeah, I think I need to check the solution. Backtracking. So rank a plane of the result and start into 0. Yeah, I almost there, right? I just try to place on the value from n to 1 at the current date. It will be assigned about the place, not 1, but okay, let's check LeetCode has any solution yet. Normally he pretty fast at this one. LeetCode.io. Nah, he don't have it yet. Okay, so I think I will figure out the rest of this one later. But good try. I try my best, you know my idea here, right? I find the current, I put it in here. I will have the helper function to check it. If it's good, I add it in. But it just turned out it's not really good at all. Are they doing the same like me? Yeah, this number is uses. Okay, backtracking. Find the second. Find the second return result. Equal. Alright, it's just my eye here in the current that plus 1 results. Okay, recursively. Oh my god. This is just evil solely because this is brute force. There's no spoon up. Yeah, it's tough for a lot of people as well, backtracking. But some guy come up with the idea really fast. Let's read this one first before I turn it off. Okay, they make it -1 if it's used. This backtracking, their first source. If on usage, return true. Array, return forms. Number of array, this is loop it back. If it use it, continue. If num equal to 0, do num equal to true. Array index equal to 1. So this is index is num, right? If num equal to phone. Nah, I don't get it. Let's go back with the LeetCode solution. Alright, that's all for today, guys. 30 minutes. Thank you for watching, and see you in the next video.